For this problem, we're going to look at hydrostatic force. So we've got a tank in the water, and the end of it is this vertical plate, and we want to calculate the hydrostatic force against the end of the tank. So it's a semicircle, and looks like it starts out at 5 feet underwater at the top, and then the diameter is 10 feet, so the radius is going to be 5 feet. So our other end here is going to be at -5. So this will be -5, and this is 0 on our axis. So force is pressure times area. So first let's look at the pressure. Pressure is given by density times gravity times depth. Since it's water, the density is 1,000 kilograms per meter cubed. Gravity is given by 9.8 meters per second squared. So we need to figure out what the depth is. So if we take a point here, the depth is going to be 5 feet plus this distance. So this distance, since we're below the axis, is -y. So my depth is going to be 5 feet plus -y, or 5 minus y. Alright, so that means my pressure is 1,000 times 9.8 times 5 minus y. Now we need to figure out area, so we're going to integrate, and we're going to do this by slicing. So my area is going to be given by this rectangle here, and this height here is dy, and then the length is 2 times x, and since this is a semicircle, x is equal to the square root of the radius squared, and the radius is 5, so 5 squared is 25, minus y squared. So my area is 2x, or 2 times the square root of 25 minus y squared dy. Alright, and we said we were going from y equals, from y equals -5 at the bottom to y equals 0 at the top. Alright, so let's put that into an integral. It's going to look like this. So force is the integral from -5 to 0 of the pressure, which was 1,000 times 9.8 times 5 minus y, times the area, which is 2 times square root 25 minus y squared dy. So that's the integral I need to evaluate. First of all, let's pull together the constant. So I've got 1,000 times 9.8, and I've got a 2 in here, and if I multiply those all together, it's going to give me 19,600, and I'm just going to pull that outside the integral. -5 to 0, 5 minus y, square root of 25 minus y squared is what I've got left in the integral, dy. Now to evaluate this, I'm actually going to break it up into 2 separate integrals. So I'll keep my constant out front here. And for my first integral, I'm just going to take this 5 and multiply it by the square root. So I'll have 5 square root 25 minus y squared dy. And then for my second integral, I'm going to take the -y, so I'm going to subtract the integral from -5 to 0 of y times the square root 25 minus y squared dy. So those are my 2 integrals. I'm going to call this one I1 and this one I2. Alright, and first let's take a look at I1. So I've rewritten that over here. And for this integral, we're going to use trig substitution since I've got a square root of 25 minus y squared. I'm going to substitute y is going to be equal to 5 sine theta. Then dy will be the integral, or the derivative of sine is cosine, so 5 cosine theta d theta. And we'll solve for theta so they can plug back in later. Theta is going to be the inverse sine of y over 5, so I'm just dividing by 5 and then taking the inverse sine to get that. Alright, so let's plug some stuff in. I'm just going to leave my bounds off the integral for now, so I've got 5 times the square root of 25 minus y squared. Now y is 5 sine theta, so I square that, I get 25 sine squared theta. And then dy is 5 cosine theta d theta, so this is my new integral. Let's do a little simplification. So first I've got a 5 here, a 5 here, and then I can pull another 5 out of the square root since I've got those two 25s there. So I'm going to pull out 5 times 5 times 5, which is 125. And then I'm going to have the square root of 1 minus sine squared theta since I've pulled the 5 out of the square root. And then I've still got cosine theta d theta. Alright, let's do a little bit more simplification. So 1 minus sine squared theta is cosine squared, and then I'm taking the square root, so that's just going to give me cosine theta here. So we've got cosine theta times cosine theta is cosine squared theta d theta, so this is starting to look a lot better. Now I'm going to use the half angle formula to change that cosine squared. It's going to become 1/2 times 1 plus cosine 2 theta d theta. And we'll just multiply that 1/2 by 125. I get 62.5 times 1 plus cosine 2 theta d theta. Alright, so let's move on to a clean page and look at that. So I've just rewritten that here. And now I'm at a good point where I can integrate. So I've pulled my constant out front, 62.5. Now if I integrate 1, I'm just going to get theta. If I integrate cosine 2 theta, I'm going to have sine 2 theta, but since I've got this 2 in here, I need to multiply by 1/2 out front. Now remember we said theta was equal to sine inverse of y over 5. So let's go ahead and plug that back in. So we've got 62.5 sine inverse of y over 5 plus 1/2 sine of 2 times sine inverse of y over 5. And I was integrating from -5 to 0. So now I can just plug in my 0 and -5 and evaluate this. So if I plug in 0 in here, I'm going to get inverse sine of 0, which is just 0 for that first term. And then if I plug in 0 in here, again, I'm going to get inverse sine of 0 is 0. 2 times 0 of 0 is 0. And then sine of 0 is 0, so I can get another 0 there. Now let's plug in our -5. So I'm going to have minus sine inverse of -5 over 5, so that's sine inverse of -1. And minus 1/2 sine of 2 times sine inverse of -1. Alright, so that's all my terms in there. So I've got 0 and 0. Let's look at this term. Sine inverse of -1. When is sine -1? That's when the angle is equal to -pi/2. So I'm going to have negative pi/2. So I'm subtracting here. So this is the same here. So this is going to be minus 1/2 sine of 2 times -pi/2. So this is the sine of -pi, and that is actually 0, so that whole term goes to 0. And all I'm left with for my first integral is 62.5 times those two negatives makes a positive pi/2. So that's my I1. Now let's look at the second integral, and this one's going to be a lot faster. So for this one, I'm just going to use a u substitution, and my u is going to be equal to 25 minus y squared, which means that du is equal to -2y dy. So let's substitute in. I'm going to leave off my bounds again, so I've got y, and this is just u. Square root of u is the same as u to the 1/2, and then dy is going to be equal to, if I divide both sides by -2y, du over -2y. So my y's are going to cancel here, and I'm just going to be left with the integral of -1/2 u to the 1/2 du. So this is easy to evaluate. We're just going to use the power rule. So I've got -1/2. I add 1 to the power, that's going to be 3/2, and I need to multiply by the reciprocal, which is 2/3. And now I need to substitute back in for my u, so I've got, let's see, these two cancel here, so I've got -1/3, and then u is 25 minus y squared to the 3/2. Now it's integrating from -5 to 0. So now I just need to plug in and evaluate. -1/3, when I plug in 0, 25 minus 0 squared is 25. So -1/3 times 25 to the 3/2. And then for my second term, -5 squared is 25, so I'm just going to have a 0 inside here, so that whole term is going to be 0. And then this is all that I'm left with for I2. So I've done both of my integrals now, and I can just put everything together. So remember, force was equal to 19,600 times I1 minus I2. And that was just, I1 was 62.5 times pi/2. And I2 was -1/3 times 25 to the 3/2. So I'm subtracting a negative. I'm going to add 1/3 times 25 to the 3/2. So that's my answer, and then if I plug that into a calculator, that ends up being 2,740,892 newtons. So that is a lot of force on the end of that tank.